Hello all, so this is going to be a pretty cool video tutorial on implementing a convolution neural network from scratch for your own dataset, for your own problem. So you keep watching this video till the end and I'll be explaining all the codes and the necessary blocks, and I'll also give the code below in the GitHub link of the code where you can download the code and try it out of your own. And this is going to be a complete tutorial and a lot of things and functions of Keras, and this is for any users who are using Keras with either Theano or TensorFlow backend. So the code is written so that it can take both the backend, and we are going to use our own dataset and train our own CNN for this. And so let's get started. So the libraries which I'm using for this is Keras 1.2.2, but there are not much differences. You can use Keras to there are minute changes that you have to do. Then for Python 2.7 environment, I'm using OpenCV 2.4.13, Theano 0.9, and for TensorFlow, if you're using on Windows, you know that for the requirement is Python 3.5.2. For that, I have OpenCV 3.1.0, and I'm using scikit-learn. So these all are in your Anaconda environment. You can watch my earlier videos of installing different libraries, Keras, Theano, TensorFlow in Anaconda environment. So that's in my channel already. So let's get started. Learning is fun, and what we are going to learn here, we are going to learn this many things today, and this is very useful for your own problem, either you're doing research or you're a neural network practitioner or hobbyist, anything. So we are going to load and pre-process our data set. We are going to design our own CNN model. We're going to train it. We are going to evaluate that model and test that model on a test image. Okay, I'm sorry for this. Yep. And then we are going to plot the loss and accuracy curve. We are going to visualize intermediate layer, confusion matrix, saving and loading, train weight. So guys, keep watching this video because you're going to learn a lot from this. And this all things I have actually done in my previous playlist video tutorial which I did last year. So it's called feeding your own dataset into CNN model in Keras, and this is another video of visualizing weights, visualizing loss, visualizing confusion matrix, and saving and loading weights. So this all things are in this current video. These all things are combined in one video, and also they are much better because with time I have learned how to like write the code in a better way. So yeah, so let's get started. And so I have a data set of 4 categories: cats, horses, dogs, and human riders. There are a total of 408 samples, and each class has 102 samples. So these are some examples of the cats, some examples of the dogs, some examples of the horses and human riders. So first let's understand the code in the slides, and then later we can implement it. So first I'm going to import OS and CV2 because that's what I'm going to use to load and pre-process the dataset. I'm going to import NumPy to since our images are kind of matrices and arrays and tensors, so kind of playing with them, reshaping them, or other things you'll see. So first of all, we are going to load our dataset. So you have to define a image row and image column size which you want your dataset to be fed into the CNN. I have defined it as 128 128, and number of channel is either you're going to use your RGB or color image. So I'm here using a gray image, sorry, RGB or a gray image. So I'm using gray image. So I'll define an image data list where I'm going to store all my 408 samples from all the 4 data classes. So in a directory, I define a data directory list where all my cats, dogs, horses, humans directories are there. So there will be 4 directories in that, and then this will loop over all these 4. So you will see that later when I run the code, and then it will reach read each of this folder. So cat folder, dog folder, horse folder, and human folder. Now each of this folder, this will read, and then I'm going to loop over all the images in each of this folder. So it's going to print loading the image of dataset cats, then it will start reading each of the 102 samples from each classes. Okay, so it will read the image. I'll convert it into gray since I'm using one number of channel as 1. Then I'll resize as 128 by 128. You can use any size for your problem. Actually this is a variable parameter that you need to tune it, and then I'm going to append it in this list. So at the end, this image data list will contain 808 samples, and yeah, so okay. and now I'll convert it into an array, and then I'll convert it into a float. And this one I divided by 225. It's kind of a normalization, so in order to get it in the range of 0 to 1, so that it converges faster, and it actually helps. So I have seen it without doing this, it takes a lot of time. With this, it helps a lot to, if your like your data set is kind of varying, so it kind of normalizes in one scale. So and then if you print your image data shape, then since I use number of channel as 1, I will get number of samples, image rows, image columns, no channels. But if you are using a RGB image, then you should get something like this at the end of this. So instead of doing this convert color, if you omit this line, and if the number of channel is 3, then you should get something like this, 808 rows, columns, and this is the number of channels. Okay, so now we have loaded the data set. Now what? So now actually I told you that I'm using, you can use this code for both backends, Theano and TensorFlow. So what's the difference when you're using Theano and TensorFlow backend with Keras? So the major difference is in image dimension ordering. So by image dimension ordering, what I mean is that in if you're using TensorFlow, then your image dimension ordering will be number of samples, number of rows, number of columns, and number of channels. And if you're using a Theano, the number of channel comes first, and then comes the rows, and then comes the channel. So you can, by importing the backend SK, you can set the image dimension ordering to TF for TensorFlow or TH for Theano. And this is for Keras 1.2.2. If you're using Keras 2, then this has changed to image dimension ordering has changed to image data format, and this has TF and TH has become TH has become your channel first, and TF has become your channel last. So this is channel last, this is channel first. Okay, so once we have imported your backend, now we are going to kind of reshape it in a format so that we can feed it into our CNN. So if you remember, if you have number of channel 1, then your image data shape was 808 128 128. Now we need to convert it into this format: number of samples, number of channels, number of rows, number of columns. And this is for the case of Theano. So for that, we'll expand dimension across axis 1 so that we get a 1 here. And suppose if you are using a number of channel as 1, and this is for TensorFlow, this was for Theano, then you have to expand in the axis 4, because in this the number of channel is at the last. So this will become 120. This was your original image which was read, original image shape, I mean image data shape, and this after expansion it becomes like this. Okay, and this is for the case when you are not using number of channel as 1 and you are just directly reading your RGB image. So in this case, if you are reading the RGB image, so you will get, you when you read the image data, it will be of shape number of samples, rows, column, and channels. So if you are using TensorFlow, then obviously this is fine for you because channel is at the end. But if you are using Theano, then you have to roll the axis from this 3 to 1. So this third axis, so this is the meaning of this: roll this image from 3 to 1. So third axis will come to 1. Okay, so now we have kind of shaped our data in a format which we can feed into the CNN. Yeah, this is another one where you can use a what to say module called pre-processing from the scikit-learn. So what this does is this will give you a zero, mean, and unit variance. So this one, when you write image data scale, pre-processing the scale image data, so what you will get is zero, mean, and unit variance for your data. But for this you have to kind of flatten your data because it takes a shape, it takes a image of shape, this shape, you know. So we are going to flatten it. So for this we are going to call this block of column. So this block of code, actually you either you can use the previous one which I told, so that by manually you subtract the mean and then you divide by 255, and this one you can use, just feed the data and it will do by itself, it will give you a final data of zero, mean, and unit variance. So what this does is it will take image size of 128 by 128, sorry, the size which you want, it will resize it to this size and then flatten it. So 128 by 128, if you flatten it, it becomes 16384. So number of samples were 808. So previously, if you remember, it was 808 by 128 by 128. So this 128 by 128 got flattened into 16384. So it's pretty simple flattening. If you have 3 by 3 image, then after flattening you should have 808,9. So once you have kind of scaled it with the scikit-learn library and you got 0 mean unit variance for your data, then again you have to reshape it in a format that it can be fed into the CNN. So that's very important. So this block of code does that. So if you're using Theano, so it will reshape into image data shape, that's 808, number of channel, image row, image columns, and if you're using TensorFlow, then obviously image row, image columns, and number of channel will be at last. So now we are done with loading the dataset. Next what? Next, once we have loaded the dataset, we want to assign labels to our dataset, because a convolution neural network is what? A supervised learning. So it's a supervised learning and we need labels to it. So I told you I'm using 4 classes, so number of classes for me will be 4, and number of samples will be the image data shape of 0, which was 808, and initially I will just give a what to say ones to it, and then later I will change it. So you can see from 0 to 10 02, this is the cats, then 10 to 204, this is my dogs, and then 204 to 206, it's my horse, and then the last one is my humans. Then you can give the names also here, sorry. Okay, so but this is just level 0 1 2 3, but if we want to use in a convolution neural network, we have to convert into a one hot encoding vector. So what I mean by one hot encoding vector is that if we have a class level of 0, then it should be converted into 100, because at the output of CNN, the number of layers in the output of a convolution neural network is equal to number of classes. So in our case it will be 4. So for each sample we should get a 4 output. So if it is a class 0, then we should get 1 0 0 0, and if it is a class 1, then we should get 0 1 1 0 1 0 0, and 2 and 3 and so on. So we convert into one hot encoding vector using nputils.to categorical. So matplotlib pyplot is used to plot the confusion matrix and graphs that we'll see later. And now another useful module of scikit-learn is shuffle and splitting. So what shuffle does is it will shuffle your data set. So if you remember our image data which we loaded, it was kind of in a sequence: cats, dogs, horses, and humans. So but if you want a better learning for your network, then it's always advisable that you shuffle your data. So I use this command to shuffle it. And what random state is used for, like, it will give you a fixed value of shuffling. I mean, the shuffling will be random, but if you give a random value, then it will, every time you run the code, it will shuffle into the same manners. And same is the case for the train test split. So why I'm doing this is because I read all the data in a one block, because I was having very less samples. So if we have a 3 different set, like a training set, uh, a validation set, and a test set, then you do not do the splitting, because then you can read from the directory by the way which I showed you of reading your all the 4 directories, data from all the 4 directories. So I'm doing this because I have less data set. So I'll split it in this X and Y, which is my 808 samples, into X train, X test, Y train, Y test. So X is the data, Y is the labels. And I will test size means how many percentage of total data you want to give it to your test. So I want to give 0.2 means 20%, and random state I'll give so that it splits it in the same way every time. Okay. So now we are done with loading and pre-processing the dataset, assigning the labels, shuffling the dataset, splitting the dataset. Now it's time to build and train your CNN. So for this, you need to import libraries from Keras, which is your will import a sequential model, dropout, activation, flatten, convolution, max pooling, and the optimizers are like this. So if you are aware with the theory part of the convolution, you know these are the building blocks of a convolution neural network which you are going to write. So now we are going to define an input shape, which is image data scaled 0 dot shape, that is number of samples comma number of channels if it's Theano, rows and columns. So this you can give it here. And then we first define a model which is sequential model. We add a convolution neural network. We give the number of filters and the size of each filter, rows, columns of each filter. So this one is the border mode, so it can be same or it can be valid, and I don't know, one more is there. The same means actually when you do convolution, if it is what to say 5 by 5 image, then it will reduce to, I guess, 3 by 3 image. but if you do same, so even after convolution it will remain 5 by 5. This all you can play with it. These are the parameters that you need to play with it. So after giving convolution, we need to give activation function, which I'm giving ReLU. So again, I'm not explaining the theory part of convolution neural network, why we need activation and what activations you can use. That you need, there are a lot of tutorials you can just go and watch. This is just the implementation tutorial. Then again, I define another convolution neural network with number of filter 32, size of filter 3 by 3, activation. Then I give a pooling of size 2 by 2, and then give a dropout. So yeah, I always forget I made these animations. Okay, so if you're giving a dropout, you can dropout is to avoid your overfitting of the data. And once we have dropout, then we kind of flatten it like we did before into an open one-dimensional vector that becomes your feature vector, and this feature vector is then uh, fed into this. These are called like dense layer, fully connected layer. This also act as a what is a classifier portion of the CNN. So yeah, and then again we give a dropout here, and the last layer will be the number of classes, which in our case is 4, and the last activation function we are going to use is the softmax function. So once we have defined our layers, so you can play with it, convolution pooling, convolution pooling, and many other things, right? That's all the theoretical part. And then once we've defined our model, we need to compile our model with giving a loss function. We are using categorical cross entropy, optimizer. I'm just given error delta. You can use anything, and matrix. We are getting accuracy. Now, if you are using Keras 2, then I guess the number of filters that you give is in one single tuple, 3 by 3. Like unlike here, we give 3 3, and I guess convolution 2D they're importing as conv 2D, and this is the shape of the channel. So in this case, I guess it was, if I was using Theano, it was 1 comma 128 comma 128. Okay, so this you can just check it, run the code and check it. So now once we have defined our code, now it's finally the training time. So this is all the 408 samples I'm having, and okay, these are all the, actually it was not 102, it was 808 samples. Okay, forget about it, you can check it while running the code. So and this is our CNN. This was the flattened layer I was talking about, and after this was the fully connected layer, and then the output. So this is not the diagram for the model which I showed you. This is just another model. So what we do, we just feed the input here, it travels, it forward propagates here, then the error back propagates here, it back propagates the error, and then this weight filters, this blocks, they get updated based on the error, and this is what the filters they're going to learn. Similarly, we give all the all the train images, and eventually the model will learn. So for training, it's a simple fit command. Sorry, yeah. So if you give a hist, you can directly write model.fit and x train, y train, batch size into how many batch size you want to train it, and obviously number of iterations you want to run for it, and the validation data. Okay, so either we split the validation data at the beginning using the scikit-learn train test split, or if you don't want that, you can just give a validation data during the training time by using validation split 0.2 instead of this one is the value which we loaded already. So if you don't want to do that, if you want to do it online runtime, then you can use this, and this hist will store the 4 variables of it, loss, accuracy, and which we can use for plotting the loss and accuracy curve. So once you run this command, you will get something like this. So actually it was not 102 samples, it was, I guess, 20 I guess it was 808 samples, so 202 samples. I gave a wrong data there, so I'll change the code there. Okay, so yeah, so it was not 408, it should be 808 total. So of that, if you split, you get 664 training samples and 160 validation samples, and it will start training. It will give you the time. It will, this loss is your training loss, this is the training accuracy, this is the validation loss and validation accuracy, and over iterations you can see how it's improving the validation accuracy, 35, 42, 54. Great. So now this I will plot it here. So this is the training loss, and you can get history, validation loss, history well loss, and if you plot, you can see that. So this is very useful. You should plot and see. You can see how my training loss is decreasing. Even validation loss should decrease, but it's there. So even the validation loss should decrease, but here jumping. So you can see the accuracy curve both should increase. So by this you can like visualize and see, okay, maybe after 15 iteration I should not train because it is not doing better my network. So this 20 epoch is very less. Practically we take more number of iterations, so just for examples I show. So after seeing this, you can maybe put a line here, okay, that maybe I should stop at this 15. And maybe even seeing the accuracy means you can see that, okay, 15 epochs seems to be better for this network. So you can plot this with this block of code, and all the entire code I will give it in the GitHub, so you can do it for yourself. This is just an explaining it. Okay, great. So now we'll evaluate. Once our model is trained, we can evaluate with this function model.evaluate on our test set, so which is x test, y test, and we can see that loss and see the accuracy with this. So for me it was not much, I guess. I don't remember, it was 60 some percentage, because it's not very good model, very less data. So, and also you can predict the value of a new image. So suppose if you take a test image, or suppose this was your x test variable array, so you take just one of the sample of it, and if you see, if you can just put it into predicting, like you can use this command model.predict of test image. So it will, the shape actually should be in this format, a number of image, number of channels, obviously you know it, and this one was with Theano backend. So if you like give a predict test image, you will get a probability value, because softmax activation function, it gives a probability of probability over all your 4 classes. So you can see it gives highest probability of 92% for the third class. I mean, yeah, so class number is 2, but class is third, and the time taken is 0 second. This is just training the time. And you can also see that what is a model dot predict classes. This was probability, and it will directly, you can see the predict classes also, which is class 2. And if you verify it by uh, printing the label, so the label was also 2, so this means 2. So you can see, although the network accuracy was not good, but still is performing well on test image. So this was from using the test image from the variable which you've already loaded. What if you want to predict the result of a completely new image? So this is my test image, suppose, and I want to predict the result of it. So I can use this code. The test image, you just read this image. You have to convert this image in a format which was used to train. So I was using a gray channel, so I'll convert it into gray. I'll resize it, then I'll convert it in array. I will do all the process that I did for defining my training set. So I'll convert into float 32. I'll divide by 255. I can print the image test dot shape, and it should be 128 by 128, obviously, because it's a single image and it's a single channel. So again, we have to expand it into a format like this for Theano: number of samples, number of channels, number of rows, number of columns, and if it is TensorFlow, then number of samples, rows, columns, and channels. So this block of code will do that. It's simple expand and roll axis, nothing big. And then you can feed into predict.test image, and it gives for me as probability of this one. So it's a human, and if you remember, the human class category was last, fourth, which was given 3, because we start assigning level 0, 1 to 3. So if you see this one, it has probability of 69%, minus 0.1 is 10 to the power minus 1, and it is the highest probability. And if you see the predict classes also, so it gives a class 3. So among these 4, so it was able to say that, okay, this test image is a human, so you are able to predict the result of a new image with this just toy model. So let's see where we are through our course. So we have loaded our preprocessor dataset, we have designed, we have evaluated and predicted the output class of test image, we have plotted the loss and accuracy curve. Now let's see how we can visualize the intermediate layer output of a CNN. Okay, so if you know the theory again, then convolution neural network is just a stacked up network of convolution, ReLU, pooling, convolution, ReLU, pooling. So if you feed an input image, so there will be a output image generated in first layer, second layer, third layer, and you can see that as it goes layer into layer, all other things goes away and only the important features stay here, and then it identify it as car or truck or whatever. Okay, I use a wrong image. I guess this is a car. Okay, oh sorry, this is a car and this is a car. I'm sorry. Okay, so let's see how we can visualize this intermediate layer output for our network. Okay, so this is the important line I've already highlighted. So the most important is this function of getting your intermediate output layer. So you have to define get feature map, you have to define model, layer number, and the input image. And this function, the backend which you imported as k, this will take your input, which is always the 0 layer, and the output will be the layer number which you define, the output layer which you want to get. And then this will be the get activation function, and it will return the activations. This is giving layer number, filter number. So this block of code will just plot one particular feature map of a particular layer. So you can see that if you that when you call this function, the activation which it returns, the shape will be of this format. So because if you remember, the number of filters in a first convolution layer, which is layer number 0, was 32. So the number of depth or number of channel in this convolution layer becomes 32. For TensorFlow, it will come like this, and for Theano, it should come like this, number of channel first. So now what we are going to do is, we are going to convert it into this shape. Okay. uh, this was the activation. If you take 0 0, so you will get in this shape. So this will be kind of image shape, rows, columns, channel, rows, column for Theano and TensorFlow. Now we'll convert into a common format. So if it's Theano, we'll convert in this, and if it's TensorFlow, it's already this, so that we can plot it in a better way. And this is for a single plot. I am plotting a single filter map. So this is a single filter map of this image of convolution layer number 0, filter number 0. There are 32 such filters. Okay, so if you want to plot all the 32 filters like this, so feature map layer 0, all the 32 filters, then you can use this block of code. So this is same as the previous one, just that number of feature map will be feature map dot shape of 2, which was, if you remember, it was the 128 comma 128 comma 32, so that will give 32 filters. Then we kind of do some what to say, normal plotting stuff with matplot lib.pyplot, which we did, and it will show you the feature maps of ith, means there are 32 filters here, so it will loop over all the 32 filters. This is the rows, columns, filter number, and then it will plot it something like this. Okay, so this is the another layer, feature map layer number 1. So if we start with 0 1, so this is one of the filter map. So this is was the convolution layer. If you remember the code, I mean the block, it was convolution, convolution activation, then pooling. So this was the convolution, and this was the activation. So since we are using a ReLU function, so it will, if you remember, if you know that ReLU, if it's less than 0, then it will make it 0. If it's greater than 0, then it will take it that value. So whatever values are greater than zeros, this kind of these features, they are getting highlighted. So this is a feature map layer number 2, and you can see this is the convolution 1, this is the activation, convolution 2, and activation 2. So I am just taking one of the feature map, and you can see as it goes deeper and deeper, so it's kind of the size gets reduced, so that's why it's getting blurry, and eventually only the features will remain. So all unnecessary information will go away. So you can see in this category of humans, maybe the leg shape is an important feature, so the network is keeping this feature, and maybe not learning all this stuff. Okay, so in this way you can visualize. Then you can plot your confusion matrix, so it will give you a idea of how your network is doing. So if you can see, this is the block of code, this is the library which you need to import classification report and confusion matrix. So you give x test and it will give you y prediction. You can print y prediction, and you can actually, the y value will be in the shape, each test image will have a 4 shape output, remember, because there are 4 channel. So we'll take argument max to get that particular class value, and we can give the class name, and when you print a classification report, you get this one. So it will give you precision, recall, f1 score, support, you have to see that. And this one, print confusion matrix, is this confusion matrix. So it will give you for 4 classes. So if you can see, there were 21 or something samples, I cut it down. So yeah, So I'll show you in a better way this one, no need to worry. And this recall is actually, it also gives the individual class accuracy. So for cat, the individual class accuracy 70%, 17%. For dogs, 11%, very bad. And for so you can see that the individual class accuracy of horse is 75% and that of human is 71%. So this is pretty simple. Now this was your confusion matrix, and if you want to better visualize it, you can plot it like this. So you can see there, now it's a better visualization of how many samples are going into which different classes. So among, you can see only 4 of the cats were classified as cats, and remaining were 5 were classified as dogs, 13 were classified as horses, and 1 was your human, excuse me. And similarly for this, you can see, so this was performing quite good. 54 of the horses were classified as horse, 7 of the horses were classified as cats, and 5 as dogs, and so on. So you can do it for your own data set just by using the structure of code. So for plotting this, it's this one. This is the, actually this is the main function, define plot confusion matrix. And actually it has to normalize. One is that normalize equal to false and normalize equal to true. So what normalize means, without normalization you get your values 4, 1, 3, and if you use a normalize means you will get divide by total, so it will be in terms of 0 point, everything will be in between 0 and 1. So that's the difference. This is the function, and to call this function, first you have to like plot your confusion matrix using the previous code and give np.argmax of y test and the y prediction, and then it will give you a matrix like this. And if you want to plot this one, then you have to call this function giving this confusion matrix which you got, and the class equal to target names which we defined previously. Target names were, yeah, this one, these are the target names. Okay, so and you will get image like this. Great. Now we have done all the things, plotted, and now if you want to save your trained model or the weights and use it somewhere else or want to give it to others, then this block of code will help. So you can import model from JSON from Keras.model and import load model. So there are three different ways to do that. First is you just save your model with JSON in a JSON file using JSON file.write, and then you save your weights using this model.saveweights, model.h5 or model.hdf5, whatever you want. And then when you want to load this model, then again you have to uh, give your model name, in this case model.json, so it will read that model in a loaded model here. And if you want to load the weights, then you have to loaded model.load weights, model.h5 or hdf5. So this is a two-step process, saving the model, saving the weights, then say, loading the model, loading the weights. Another way which I oftenly most of the time use is this one, where I just directly save the model along with the weights. So once you've trained your model, those weights in that model are fixed, so they are there only. So you can just write model.save model.hdf5 and it will save the model along with the weights, and then you can load the model using load model model.hdf5. Okay, so that's all. I guess we are through with loading dataset, designing, evaluating, plotting, visualizing, plotting the confusion matrix for your result, saving and loading the train with and models. And I was hoping to show and show you the codes also in Spider environment, but I guess this video is getting very long, so I'll do it in the next video maybe. But whatever I explained, that is the essence of this tutorial. If you understand that, uh, you can change those parameters and put your own data set, your own maybe target names, number of labels, and train your own network and visualize all this stuffs, this cool stuffs. And I'll give you the code below. Okay, so this is the entire data set. This is from my previous video of embedding visualization using TensorBoard. You can see that also, that is pretty cool. And thank you for listening me and watching this video, and keep watching for more such implementations. I am just like you, a practitioner just try to implement all this stuff. And any doubt, you can comment below. So like and share among your friends who are trying to learn neural networks, and I'll give the code below. So bye bye, and keep learning.